desktop. Dinesh, RTK Lib. So before we start about RTK Lib explanations, so we are going to, learn again about receiver used in this training. So as you might know, there are two types of receivers. The first one is U-blocks, right side. This one, U-blocks MAT and M8P, and also patch antenna. And a trim blue net R9, this is a survey grade receiver and a trim blue antenna. It's very big. So I actually use these two types of receivers in this training. Actually, you can purchase the M8T U-blocks receiver in this CSG shop. You can search CSG shop U-blocks. So $75. It's still there are many left items in stock. So you can, if you purchase this product, you can evaluate the RTK by yourselves using RTK Lib or maybe your own software. So some data used in this practice, we prepare 3 sets of data, 24 hours static raw data at Kaiodai. Kaiodai, I belong to Tokyo University of Marine Science and Technology. My university location is in nearby Tokyo Station. And the second one, static raw data using 1 hour data, U-blocks and trim blue. And finally, kinematic raw data using the automobile car, also U-blocks and trim blue. And 30 minutes, 0.5 hour. So you will learn in this webinar using the RTK Lib free software. And maybe you can try the real-time RTK using your smartphone or internet, plus N-trip server. You can check RTK by yourself. And through this webinar, you will learn how to process RTK Lib in the post-processing or real-time processing. Today, I am focusing on post-processing. So you need to decide which is more important for your purpose. Maybe some researchers uses only post-processing, but some of them are interested in real-time processing. So please keep in mind that there are specific terms in Genesis. So that's why I try to explain the specific terms, difficult terms in Genesis. So as you already might know, RTK tells you, RTK, real-time kinematic, this solution tells you, this method tells you not absolute position, but vector from base station. Vector means from base station to user, rover stations. So once you determine the precise position at the base stations, for example, X left, Y left, Z left, EC, EF coordinate, you will know the precise vector from base antenna to rover antenna. So like that. And then you will know your precise position, your user rover station user position XYZ is equal X reference, Y reference, Z reference, plus dx, dy, dz in 3 dimensions. So RTK tells you only dx, dy, dz. So there are 3 types of positioning method, 3 types results of the based on the 3 positioning methods. The left one is standalone positioning, and the scale is here. This one 50 centimeters. The middle one is differential genesis. The right one is RTK. As you can see, there is a big difference between standalone positioning, differential genesis, and RTK. RTK is quite good. It's the different regions. because 1 centimeter, so maybe millimeter level. And differential genesis is decimeter level, 50 to 50 centimeters. And a standalone positioning is always 2, 3, or 1 meters. So these three figures, same scale. So, and also results was obtained in our building rooftop, 12 hours. Okay, I will skip this recent test. And so there are many reference stations in Japan. So we have about 1,300 base stations for RTK or something. I would like you to know the difference between expensive survey-grade receiver and low-cost receivers like U-Blocks, Skytrack, or other manufacturers. So the difference between survey-grade receiver and low-cost receivers. Cost and multiple genesis, survey-grade receivers almost all perfect. Low-cost receiver, for example, U-Blocks, Beidou or GLONASS, and other GPS Galileo, QGSS are okay. A multiple frequency, a survey-grade perfect, and a low-cost receiver, until now, only single frequency. It is single frequency is not true, but we say single frequency. Actually, L1 frequency for GPS, QGS, E1 frequency for Galileo is the same center frequency. However, Beidou B1 frequency is 10 megahertz difference. But we say like single frequency. Number of channel capacity, survey-grade receiver is currently more than 400, 500. Low-cost receiver is under 100. And the RTK short baseline, open sky, both of them almost perfect. And 20 kilometer baseline, over 20 kilometer baseline, we say middle baseline, medium baseline, open sky, survey-grade receiver almost perfect, but low-cost receiver impossible. Sometimes okay, but almost impossible. And RTK and mid-obstructed area, survey-grade receiver almost perfect, and low-cost receiver may be difficult. So dense obstructed area, even survey-grade receivers sometimes not good. And accuracy of fixed positions, RTK fixed positions, the accuracy is same. Once you have fixing ambiguities solutions, so the accuracy is same. The accuracy of curved position is a little bit different. So survey-grade receivers always 20, 30, 40 centimeters, but the low-cost receivers is 1 meter. So this table summarizes error source mitigations in very typical case. Here is the source errors. So we divide it. Usually we divide 6 error sources: satellite clock model, satellite ephemeris, ionospheric, troposphere, and multipath and receiver noise. And single point positioning, final solution is always 2 to 3 meters, but each error sources is divided into like that: ionosphere, troposphere, and a single satellite clock, satellite ephemeris. The differential genesis final solutions is within 1 meters because we can mitigate ionospheric delay and tropospheric delays using the base station's correction data. On the other hand, multipath receiver noise is same. We can't mitigate multipath receiver noise. RTK PPP, as you already know PPP, so RTK we can reduce completely satellite clock, satellite side error, and ionosphere, troposphere. In the case of 10 to 20 kilometers, almost zero. So that's why we will see the final solutions. 1 centimeter is equal to the noise of the carrier phase. And PPP, so PPP, as you know, the precise clock and precise ephemeris is broadcasted from satellite or via the internet. And the ionosphere, so they will converge the dual frequencies, ionosphere free combinations. and a troposphere they estimated very correctly. So that's why finally several centimeters accuracy they have. Okay, let's move on to the RTK review practice. So I'm going to introduce about RTK Live using the 10 slides. RTK Live is an open source software package for GNSS positioning. It has been developed since 2006 by Mr. Takasu. The latest version is 2.4.3 and not 2, maybe beta 29 or something like that, distributed under BSD license. So portable APIs and useful applications. There are several APIs and applications. Also, command line applications you can use. So if you are interested in this software, or if you'd like to know more in details, you can check this website and GitHub also. So this is just an example of the RTK applications. Professor Ota in Tokyo University, he wrote the paper using the RTK Live test results after the 2011 very big earthquakes. You can see, so the base station is in here, and RTK Live tells you the more than 1,000 kilometers centimeter level movement of the ground cluster. So 400 seconds, 430 seconds. So it's like that. So in total, maybe more than 5 meters deformations we could see just after the very big earthquake in Tohoku area. So these animations probably made by this Professor Ota sensei. Okay, so here is the history of RTK Live. So 2006, he started to this program and the first version for RTK C program. And maybe, yeah. Anyway, so 2009, he started to distribute as open source software. And RTCM network, RTK, and he cope with many receivers and support not only GPS but also GLONASS. And 2011 support the QGIS because QGIS was launched. And 2013, 5 years ago, support Galileo, started to support Galileo and enable Beidou, B1, B2, and yes, now. The features of RTK Live. So standard and precise positioning algorithm with merge GNSS, including SBUS, real-time and post-processing by various modes, single point positioning, SBUS differential correction, differential GPS, RTK, and static mode, and moving base, and PPP. So moving base means, as you might know, GPS compass uses this method, moving baselines, to support many formats and protocol and receivers. So you don't have to develop the RTCM3 input stream or Binex or N-Trip. You just use this API or applications. So many varieties of formats and protocols. It is very helpful to reduce the software development time consuming. It supports real-time communications via TCP/IP and N-Trip and other file streams, and of course serial. So this is just a GUI of applications. It's quite good. So command line applications. To be honest, I actually use now RTK, RCV. It is very easy to change the software, to modify the software in terms of RTK. And other applications, other API also can be used in command line versions, maybe Unix or Linux. something like that. So package structures. So source code and source program depending on GPS GNS receiver, so our receiver type, and executable binary applications and sample data, and the build environment for applications. And these are the applications. RTK Navi, this is real-time RTK. STR SVR is later I will introduce. RTK Post is post-processing mode. MKL test to utility and a document file. So API, I will skip this slide because it's very small character. So there are many variety of supported receivers. Of course, uBlocks. Here, format RTCM 2.3 and RTCM 3.1. Unfortunately, I think that RTCM version 3.2 and the newest version of RTCM maybe is not supported now, but I asked Mr. Takasu to modify, to create the very latest version of RTCM. Novatel OEM4 and OEM Star and OEM 5. Novatel OEM3 is very old receiver, Superstar 2 and the uBlocks 45T and the 8T and the M8P, okay. Hemisphere and the Skytrack and Java and Flume. So this is GUI of the visibility of the sky view of multi-genesis. So multi-genesis supports GPS GLONASS and Galileo, QGIS, Beidou, and SBUS in 2013. So if you need to read manual, so you can refer to the RTK version 2.4.1 manual. Probably this is the newest one in terms of manual. So you can also refer to the support information in this RTK website. And if you use RTK heavily, so please check this website because Mr. Takasu, at least he commented about the support information about RTK lib as soon as possible in this website. Okay, so let's move on to the RTK lib practice. I am not sure if you already installed RTK lib or not. Dinesh-san?
Yes, I think only very few of them, they have RTK lib.
Yes, yes, okay.
So they need to know from where to download RTK lib version 3.26 because I could not find the binary as well.
Yeah.
Later, please tell them from where to download RTK lib. I think today, maybe, I don't know. If anybody today who already using RTK lib, can you send a message in the chat if you are using? So we know how many already using RTK lib. But we had some questions in my previous webinar related to RTK lib. So we have some users actually. Yes, there are some users. So some of them they know, but I think many of them probably it's new. Yes. Okay. So nevertheless, so let's just finish this webinar, and please send me this PDF file, today's presentation file. So I will send to all the participants, so they can refer it and download RTK lib and practice.
Yes.
Okay.
So which means I need to send the PDF?
Yes, to
as soon as possible.
Yeah, after this.
After. Sure. Sorry, I don't.
After the webinar or tomorrow, it's okay. So I will send by email to everybody, and also I will put in the website so that they can also download. Okay. Yes, please.
Oh, basically, very interesting group chat. So when will RTK support IRNSS?
Okay.
IRNSS. So I'm sorry. Maybe Mr. Takasu does not plan to support IRNSS.
Yeah, maybe because I think this question is from from the Burdwan University.
Yeah.
And from Mr.
Thank you for
Mahathir,
your
I
question.
think,
Yeah.
but they have I think very large participants in the last meeting as well, and they
Yes.
have IRNSS receiver. So maybe
Yeah.
we can collaborate with them to make some additional function for RTK Leave, or they
Yeah.
can implement for RTK
Yes.
because they know more about IRNSS than we do. Okay.
So, okay, thank you. So,
Yes.
okay, back to slide. So maybe some of the participants do not have RTK lib, or some of them have RTK lib. But okay, I'm going to introduce how to install RTK lib, and also I will introduce the GNSS test data in static condition and kinematic conditions. And I'd like you to try to test the post-processing mode in RTK Live after this webinars, if you have a time, when you have a time. So next. So as you know, there are two modes in RTK, from base stations to lower receivers. So RTK tells you the vectors from base station to lower stations. And the two modes, one of the mode is post-processing. Post-processing mode, all you need is observation data and navigation data, both in reference station and lower stations. So which means you need to obtain the observation data and navigation data simultaneously, both in base and lower stations. So usually we use Linux data because most of commercial receivers can convert from binary on format to Linux format. So we actually use Linux format in this post-processing. On the other hand, so there is of course real-time mode because RTK is short for real-time kinematic. So if you'd like to use real-time mode in using RTK Live, of course you need communication link. And then, so differential data reception are required using RTCM or NTRIP. And what if you don't have receiver correction data for 1 minute or 30 seconds or maybe 2 minutes, 3 minutes? So RTK, please make sure that RTK requires the robust communication link. So this is a kind of demerit of RTK because continuous data link is sometimes difficult, even in Japan. Yes, I checked 24 hours real-time RTK just 1 week ago, 24 hours at our campus. Baseline is only 100 meters. And we used SIM card, smartphone SIM in tethering. And the result is 24 hours, 24 hours continuous 1 Hz data, and 800 epochs are skipped due to the communication links of the SIM card. So this is the kind of limitations of continuous, in terms of continuous data link. And how long can RTK, probably you have a question, how long can RTK keep their fixed solutions without correction data? So I can't answer correctly, but some receivers give up 10 seconds, like Trimblue and Topcon, receivers give up 10 seconds, they set 10 seconds later, they will switch from RTK to differential genesis. And some receivers, maybe U-blocks, can keep 30 seconds. It depends on. And also, it also depends on the environment. If you are in the under multipass environment, even 5 second fixed solutions will be changed into the float solutions or differential genesis because of the multipass issues. And RTCM N-trip. RTCM is just, I will read, standard for differential global navigation satellite system was defined in RTCM Special Committee 104, and its current version is version 3. So it stands for Differential Global Navigation Satellite Service, communication protocol between reference stations and the mobile receivers. Almost all commercial receivers adopt this RTCM format. So that's why please remember this name, specific term. And N-trip is also important term. So N-trip was also defined in the RTCM Special Committee 104. It stands for Networked Transport for RTCM via Internet Protocol. It is based on Hypertext Transfer Protocol version 1.1, and the intention is to disseminate differential correction data through the internet. So that's why many of you set the N-trip servers. Because without N-trip server, it is difficult to transmit, it is difficult to implement RTK by yourselves. If you use VRS correction data or commercial correction data, it is okay. But if you develop the base station and the low pass station by yourself, you need to set N-trip server by yourselves. Otherwise, you can use just radio communication links. So I prepared the RTK Live 2.4.3 beta 26 compressed versions in this website. If you have when you have a time, please download this RTK Live software. And the 3 types of data I prepared. I will introduce these post-processing mode using these data. So this is a website and RTK Live zip, 1 hour data and 24 hours static data, 1 hour static data, 24 hours static data, and car data, so moving data. So you can refer to the latest update in this GitHub, but probably 2.4.3 is the latest versions. And I talked to Mr. Takasu last month, and he is going to modify the RTK Live soonly because the U-blocks F9 receivers will be released in the near future. So here is U-blocks Neo M8P, and so this slide just shows how to set up U-blocks receiver and the U-centers. So U-center, actually you can search U-center in Google, and you will be able to find the U-center setup zip file version 8.26789, or I'm not sure. Maybe latest version is 8.30 or something like that. So if you have laptop or not laptop, maybe PAT and USB and patch antenna and the U-blocks receiver, so you can check the RTK engine in this U-blocks receivers. But of course, you need the correction data from the base stations. So I have a question. So do you think which is good? Which is good? So if you test the RTK using like this small antenna, patch antenna, please use the kind of 10 centimeter or 12 centimeters ground plane below this patch antenna. Always better than the left examples. So only patch antenna is not good because the carrier to noise ratio can vary very largely in the case of left type, left one. But the right one is the carrier to noise ratio is quite stable. And probably the difference between right one and left one in terms of carrier to noise ratio, at least 3 to 5 decibels. It is quite important, especially in RTK. So, yeah, start U center, and so yeah, maybe I will skip this one, but you can do it by yourself. So port setting. And you will
Kubo Sensei, I
yes,
think
yes.
I have covered this in the
Okay, thank
first
you.
lecture, so it's okay.
Okay, I skip.
And
yes.
Also we have a very detailed handout, so we can see these slides.
Yes, yes, yes.
Okay.
Sorry, skip. And okay. After you obtain the, yeah, you already know. After you obtain the low X, this is, sorry, uBlocks version. Observation data in low X is like that, shoot range and carrier phase Doppler frequency. And the navigation data, SFR BX, like that. After you obtain these data, you can convert using RTK comb. And it is very easy for you to convert because no difficulty. There's no difficulty. Okay, I skip this one. So execute RTK launch. So this is version 2.4.2. So there are 1, 2, 3, 4, 5, 7 applications. RTK plot. This is just a plot application. RTK conversion from binary data to Linux data. And STR SVR is the communication tool. And RTK post processing and N-trip. Sorry, I never use this one. RTK nav is a real-time RTK, and the RTE get. Sorry, I don't use this one. So if you launch, after you launch RTK launch.exe, you will see this one. So now we will see RTK post. So the right figure shows the RTK post GUI, and execute menu of RTK plot and load. Sorry, I will check in this desktop RTK plot, RTK post. Sorry, not this one. Yes, use RTK. This one. Okay. So this is the binary RTK post. So of course it is same 2.4.3 B26 and network 9 net data you can also download the 24 hours. Interval is 15 seconds and network 9 here. And navigation file, sorry, it is difficult. Then I know. Sorry. 24 hours. Navigation file. And if you click here, so you just put observation data and the navigation data only. That's all. And the options we set a single standard positioning. Anyway, so if you click this one, reading observation data, updating azimuth elevations, updating multipath, probably code minus carrier difference. Yes, like that. So 24 hours, GPS and GPS. Oh, sorry. This is only GPS. So if you'd like to see as a satellite, you just click here, options, and maybe you can put QGIS and Beidou. So like that. So QGIS J01, J02, J03, and Beidou 1 to 14. So okay, this is new data. When? Sorry. This year, January 19th. So that's why we can see the 3 Japanese satellites here. Okay. And the next page. So you can check which satellite is available in 24 hours. Not only GPS, but also other satellite. Okay. And Skyplot. Skyplot, you just change here, satellite visibility to Skyplot. So you can see Skyplot. So 24 hours transitions. The many, too many. 数値 statistics. Okay. So visible satellite and DOP. So change it to DOP and the number of satellite. So I set GPS Beidou QGIS. So that's why the number of satellite over 0 degrees, 20 to 25 in Tokyo. And the DOP is quite low. So if you set additionally GLONASS and Galileo, much more satellite, sorry, I どうするんだっけ違うな。I'm sorry. So over 25, over 30 satellite. So this RTK plot options, the left side is the observation data options, and here is solution data options, and the right side is common options. So the maximum satellite I need to set to 50. So you can see the 5 types of satellite if we use in Tokyo. So 30 to 35 satellite you can see. And also statistics shows the number, the percentage of each number of satellite. So I hope you will enjoy this RTK plot after this webinar. Okay, let's move on to RTK Post. So this is RTK Post. Okay, setting 1. After you launch RTK Post, now we will test standalone positioning. So here, options and setting 1 is the main settings, single standalone differential kinematic, RTK or static, moving base, fixed, PPP. Okay, I set single. Single frequency is forced single frequency. And elevation mask angle 15 degrees. And here, if you click here, right side of SNR mask decibel hertz. So if you check lower satellite, if you check lower you can set the minimum carrier to noise ratio required for the positioning. So L1, each frequency, L1 frequency, L2 frequency, and L5 frequencies. But unfortunately, it is not corresponding to the B1, B2, or other frequencies. So you can set each satellite elevation angles. But 35 degrees is the kind of suitable threshold in the case of very multipath environment. So please remember that. Yes, base station is usually very open sky conditions, so that's why you don't have to set the base stations. Okay, I skip this one. 15 degrees and ionosphere collection broadcast model, and the Samoine is just a model and a broadcast satellite Jimenez clock. And GPS, Galileo, QGS, Beidou, and GLONASS, so 5 satellites set. And the output is you can choose a format XYZ or latitude, longitude, and output to header processing mode. And I usually use this one, second GPS time, ne? WGS. So okay, so let's do the execute. So I hope it's finished. Yes, not so long. So if you calculate every one epoch data for 24 hours, it takes a lot of time. But this is interval 15 seconds, and plot, I am not sure. Yeah, like that. Yes. So this is the result of the 24 hours interval is 15 seconds, and using multi-Genesis. And of course, the flag is 5 means standalone positioning, and 100% solutions because of open sky conditions. And you can see the standard deviations in longitude 50 centimeters, and latitude 60 centimeters, and the upper is 1.7 meters. If we'd like to see the temporal variations, it's like that. But much more important is if you change the coordinate origin means here, 0, 0. If you change the coordinate origin as a precise reference positions, so you need to change in the options, coordinate latitude, longitude, and 5.666 like that, and 139.792 792 2010 かな。So this is our preset positions in January, I guess. So like that. So here is the preset positions, but the standalone position is tend to deviate like that. So maybe 1 meter deviations, 1 or 50 centimeters deviations, and like that. This is a standalone positioning. Okay, next is differential genesis. So differential genesis, if you'd like to check differential genesis, you need to push. You need base station data, of course. So base station data here, and lower station data here. So lower station. So base station, options, setting 1, of course, you have to change differential GPS and single frequency, and I skip GLONASS, Galileo, GPS, QGIS, Beidou. Okay, and back to the 1 hour data. 1 hour data reference of. Okay, this is good. So reference observations here and the lower observation here. Sorry. Data 1 hour reference observations and navigation file. Okay. So this is 1 hour data and the reference data and net R9, trim net R9, and the global data trim net R9. The options, as you already said, differential genesis and single frequency is same. And then you need to check the positions of this. So 33444921010. Maybe it's almost same. Setting 1. Okay, execute. So flag is equal to 4 means differential genesis, differential correction. Solutions and a plot is, I hope it's okay. So like that. And yes. So of course the accuracy is slightly better than single point positioning, and you can see the average of 3,600 epochs here, and you can see here latitude longitude. So 35.666270 is matches with the precise positions, which means the centimeter level average is matches. 139.79226. It's also matches with 6 decimal. It's centimeter level. And positions, sorry, so this is only, okay. Anyway, so this is differential genesis. So next one is RTK. This is the last in this webinar. RTK Kinematic. Okay, let's do that. Option, and you will change in setting 1 from differential genesis in kinematic, and L1 single frequency may be okay. Setting 2 is this does not show. Okay, let's try instantaneous. Instantaneous means single epoch solution, single epoch observations was used. And the continuous Kalman filter and the fix and hold is maybe later I will, maybe next week I'm going to introduce. Output statistics position is same. Overwrite. 大丈夫かな? 大丈夫かな? Okay. Yeah, Q flag is equal 1 means fix RTK fix solutions. Mm, 6 meters. Okay. Yes. So you can see the RTK fixed positions. So it's very accurate. So the scale is 2 centimeter within 2 centimeters, almost. And if you choose only RTK fixed solutions, 3,650, so which means 99.7% fixed. If you use survey grade receiver and only single frequency, not the dual frequency, only single frequency. So if you see the same scale, no, 20 centimeters. Like that. So totally different from differential genesis and RTK. In this case, here is the base stations and only 7 or 8 meters difference between base station and the low base stations. Of course, it's the same relationships in differential genesis. Here is base station and the differential genesis. So RTK and the differential genesis. So today, I am going to finish today's webinar, but I hope you will exercise same as me. Just I introduced last 10 to 20 minutes, only 10 to 20 minutes. So if you have issues, difficulties to download the data in the slide where slide 31 or 32, please email to Dr. Dinesh or Dr. Kubo. Yes. Dinesh-san?
Hi.
Sorry. So
Yes.
I'm going to finish. Yes.
Yeah. Okay. So the presentation is over. You
Yes.
finished. Okay. Okay.
Yes.
So let's ask whether the participants they have some questions.
Yeah.
Yes. So last time there was a question that because I showed some data in the kinematic mode when like your data was we logged the data by car driving.
Oh yeah.
The RTK leave so the error to the RMS error. So what does it mean in the case of the kinematic? Because the car is driving and it gives you the 2D RMS error. So that was one question in the last presentation. And maybe today, so if you have other questions, so please send us. So can you explain this 2D, the error in the kinematic mode? Because it's changing, okay, every observation.
Yeah.
So we can't have some average RMS error.
Yeah. So in kinematic mode, RMS errors, so it's, we cannot use this one.
Yes.
Yes.
So
you know.
I didn't have an answer
should
for
know.
that. So I told them that today we have expert.
Yeah. Sorry, yeah.
Okay, good.
Because RMS standard deviation is we need to set precise positions.
Yes.
The kinematic mode is, impossible.
Yes.
Impossible.
Okay.
Yes.
Okay.
Do you have any questions?
There's one question that can we use a base receiver as N-trip server and cluster both? If yes, then how? But I think this depends on whether your receiver has an N-trip caster function or not.
Could we use base receiver as N-trip server and cluster?
N-trip cluster.
Cluster, ne.
N-trip server and N-trip cluster.
What does it mean? Could we use base receiver as N-trip server?
N-trip caster. So what he means is that like a NetR9.
Yes.
So NetR9, if we use as a base station.
Yes.
NetR9 can be set up as an N-trip caster.
Caster. Okay.
Not a server, as a caster.
Server, yeah.
So that other users from the field they can access using the IP address of the NetR9. And that will be like, it will have an entry address. Like, so we can set entry inside the NetR9. So this is possible.
So this question means, as I already introduced, or maybe we have to set up N-trip server. And once you set up N-trip server, you can use anything.
But can we set that N-trip server inside the base station? So this is the question.
Can we use base receiver as N-trip server? So this means the answer is NetR9. U-blocks impossible.
U-blocks is impossible.
Impossible, yeah.
Yes, but in
Topcon, like survey-grade receivers can do that.
Yes, I think so. For example, in the case of NetR9, so if I have NetR9 and if I have a fixed IP address, so do I still need a separate N-trip server?
Separate?
Yes. Do I need it? For example, in the base station in Kaiodai, you have a Sakura server.
Yes.
But do we actually need that Sakura server? Can we access the entry?
No. If you have like trim receiver, you don't need it.
Yes, we don't need it because the receiver inside has all the necessary software or hardware.
Can they participant?
Yeah, we can see.
You can see?
Yes.
So this is another server, caster, even client, everything you can set up.
Yes.
So you don't need any trip server because it is included in receiver software.
Yes.
Okay.
So it depends on the receiver that you purchase. So when you purchase, please ask the manufacturer or the seller whether they have the N-trip server and caster functionality in the receiver. Some receivers they have included inside. Some receivers they don't have it.
So many time we have observed that speed up is very high, more than 50. How it comes due to multipass? No. DOP does not relate it to multipass. DOP depends on the satellite constellation. More than 50 is quite large. Speed up. Okay. More than 2 post file can we plot at the time in RTK? Yes. So next week I will introduce. Sorry. Sometimes we not get DOP from RNX of file using RTK Pro. What is the reason behind? Sometimes we don't get DOP. Maybe too short number of satellite? Under 4? Can we plot 2 post file in RTK? Yes. You can plot 2 post file in RTK plot. Because 1, 2. 1, 2. Okay?リレンさん、そろそろいいかなこれ。Okay, everyone okay?
Kubo sensei.
Yes.
So there is one question. Is there any formula to find accuracy parameters like 2D RMS in dynamic condition? So again, is this possible? I don't think so.
I don't think so. So if you would like to check the kinematic 2D RMS or standard deviation, of course, you need reference positions, and you cannot use RTK label. You just use Excel or something like that. For example, my slide next week, if I have a chance, I will talk about the kinematic data. So in kinematic mode, so slide 71. So this is 1, 2. So one is sorry. The left one is RTK results using Trimble, and the right figure shows the post-LVX result. Post-LVX means post-process RTK and FOG and speed sensors. It's generated the very precise positions in 100% in normal urban area. And if you click this one, if you click 2, this one, and if you click 1 minus 2, so you can see the difference between in all epochs between two results. So this is very convenient. And probably you will see a kind of standard deviations or RMS. You know, for example, in this case, only several centimeters because scale is 10 centimeters.
So this means that if we have a kinematic data like this,
yes,
like 2 data sets, and we plot in window 1 and window 2, and
yes,
we take the difference between 1 and 2, because they are the same data set. So if we get the difference, so we have some errors for every corresponding point. So using those errors for every point, we can estimate some error. And that can be a 2D RMS or whatever.
2D RMS, maybe Excel, maybe we should use, Yes,
so in that sense, yes, for kinematic, we can calculate some error like this way. But if we want to know the error for each individual point, so maybe we have to do point by point, like
point by point,
Excel.
Excel,
do data set and find the difference. But we just have a because we have only one sample at one point. So we just get a difference. So we don't have a mean or something. Because in order to calculate the mean, we have a number of samples, n. But in this case, if we compare epoch by epoch, the number of sample is just 1. So it doesn't make any sense of calculating the mean or anything. But if we compare as a whole the data set, so we can do 1 minus 2, and we can compare the mean or standard deviation for the whole data set. Okay,
thank you.
So yes.
So we want to send the RTC message from one base to many. So actually already send RTCM 3.2 to many users in my base stations. So it is automatically can be set if you have a survey grade receiver.
But if we don't have survey grade, so maybe we need to set up Ntrip server.
Yes, like Ntrip server and uBlocks.
Yes. So if we have, say, uBlocks base station, so we need to have an Ntrip server, and then we can broadcast using the Ntrip server. So we say the caster, and then in the field we have the Ntrip client. So from the field, it will access the Ntrip server to get multiple. To get the base station data from the multiple users.
Yes.
Okay, so thank you very much for today's webinar. So please send me this PDF file. I will send and upload in the homepage.
Okay.
So I think that's all.
That's all. Thank you.
Okay, thank you very much.
Thank you.
Okay, still, yep. So we'll have another seminar on 8th of June. So please attend. So we'll have for the kinematic. Probably you will have more questions and answers. you will also get, and by that time you can also download the software and some sample data. So please try at your site so that you can see how actually it works. Okay, thank you very much.